Hi friends, so welcome to our today's discussion and we will be discussing language of mathematics, no, in this day. Okay, so let us start. So we have mathematical language, no, it is defined as the system used to communicate mathematical concepts and ideas, consists of some natural language using technical terms and grammatical conventions, supplemented by symbolic notation for mathematical formulae. So basically, mathematical language, it is something that we use when we want to convey something that is that is math in nature, basically. No, so for example, if you want to say, let's say, you have a handful of fruits, no? So, meron ka isang buong bag ng mga prutas. Then, gusto mong tinanong ka, ilang prutas, I mean, ilang piraso kada prutas ang meron dun sa bag, no? So, you're going to use mathematical language to answer that question. Okay? So, you will just, let's say, you will count, no? How many are apple, how many are banana, yun, so on and so forth. Okay? So, characteristics of mathematical language, no? So, mathematical language has three main characteristics. So, first we have precision in mathematics is like a culture of being always correct, no? So, precision is very important in math, no? So, why? We cannot express mathematical concepts na mali, no, basically. Kasi it's the nature of the math. Math should always be correct, 'di ba? So, for example, unlike in English language where you can commit grammatical errors, no? So, which is sometimes it is quite forgivable kasi for example, lalo sa atin mga Filipino, no, we are not actually I mean hindi tayo nagsasalita ng English right away after we are born, no? So, we actually learn English as our second language. So, somehow it is quite forgivable na, for example, if we commit grammatical errors, no, in the most basic sense. However, no, in math, you cannot commit even a single slightest mistake. Bakit, no? In mathematics kasi, if you have committed a small mistake, it will eventually lead to a bigger problem, no? In the run of your theorem, let's say you are creating a theorem or a law, you are proposing a theorem, no? And it is, of course, may mga mathematical expressions yon. I mean, may mga mathematical concepts yon na nagsosolve where you solve for certain values and test, no, the hypothesis if it is acceptable or not. No, hindi tayo pwedeng magkamali because it will risk the integrity of the idea or of the concept. Okay? So you need I mean, mathematics should always be correct. Next, we have concise or display simplicity. Shows desire in the simplest possible exposition. Alam natin na ang math ay mahirap. No? Given yun. No? I'm not denying that mathematics is hard. No? However, no, despite of the hardship ng math itself, no, we can actually express math in the simplest manner. For example, no, uh, pinapa-define sa atin yung gravity. Let's say, no, gravity in physics. Alam natin na meron tamang derivation ang gravity, which is quite complex, 'di ba? But it can be simplified to a certain value, 'di ba? Which is what we all know, 9.8 meters per second squared or 32 feet per second squared. No? So, ayun, no, yung mga ganon. At saka yung kapag, di ba, nagsosolve tayo ng mga math, let's say, nung high school or ngayon, no, sa college, we always express it in the simplest form, no? Kasi, bakit? We want to directly convey the message in the simplest way possible. No, yung message ng math na gusto natin i, i i-convey or i-send sa nakikinig sa atin, sa audience, is something that is understandable, no? Even the simplest, I mean, even yung mga people na not really into mathematics, maiintindihan nila, or else it will be intimidating and it will not, I mean, the message will not be conveyed, basically. Okay? And we have powerful, no? So mathematics is a powerful language, no? It can express things that are not expressible or that are not quite easily to be understood using other language. For example, sa English, sa kung ano man kung ano mang language 'yon, no? And mathematics is a universal language. Everyone do math, no? For example, not everyone do English, 'di ba? Hindi hindi lahat ng tao nakakapagsalita ng English. But almost everyone can count, 'di ba? Even the simplest counting, no, 1 to 10, no, yung mga bata nga marunong, 'di ba? So, yan no, yung mga ganong bagay, no. So, kaya siya naging powerful kasi it creates bridges with different groups of people. Okay? So, yun, that's the characteristic, no? So, sabi ni Galileo Galilei, mathematics is the language in which God has written the universe, which is actually true kasi 'di ba? Everything that in the universe that we see, no, it is actually governed by math. For example, yun nga yun theory of relativity ni Einstein, 'di ba? That's governed by math, which tells yung behavior ng mga sun or ng ang behavior ng stars, ng mga planets and everything around our space, no? So for example, paano nakakarating yung sinag ng araw mula sa araw papunta sa Earth, no? So that is governed by mathematics, diba? So it travels at the speed of 8 I mean it takes 8 minutes, no, to travel the light wave from sun going to Earth. Things like that, no? So yun yung mga ano natin sa ano na to dito sa statement ni Galileo Galilei. Okay? So mathematics family tree, no? So actually we have several branches of mathematics and we have different forms of mathematical concepts, no? But we will just focus on this specific tree, no? So we have here we will start with the complex numbers. Ito kasi yung pinaka madaling maintindihan sa totoo lang, no? We have a plus bi or x plus jy, where complex numbers actually is composed of two parts, no? The real part and the imaginary part. Yung real part yun yung walang I or walang J, then yung imaginary part is the other one, no? Yung merong I or merong J. So with that, it is divided into two, no? So when we say complex numbers, we have two, the real numbers. These are complex numbers without imaginary part, no? So ibig sabihin 0 yung imaginary part natin dito sa real numbers. So we have 0, -2, 10, 5 over 2. Yung mga usual na numbers na alam natin. Okay, those are real numbers. And when we say imaginary numbers or imaginary part, the imaginary part of the complex number, these are numbers that are associated with the imaginary number, which is I or J, no? It's just the same, dalawa lang yung notation niya. Or the numerical value of square root of -1, no? So yun yung imaginary number natin. Then balik tayo sa real number. When we say real number, it is divided into two pa. Now we have the rational numbers and the irrational numbers. Irrational numbers, these are numbers na non-repeating, non-terminating decimals. That's the main definition of irrational numbers. So we have pi, e, no, the golden ratio, tau, so on and so forth, no? So mga non-repeating, non-terminating decimals natin. Okay, irrational numbers yun. Then we have the rational numbers, no? So these are numbers that are not irrational basically. No, yung mga ano ba yung mga rational numbers natin? So we have the repeating non-terminating and the non-repeating terminating decimals, no? So those are rational numbers. Then rational numbers are divided into two ulit, no? So we have the integers and the non-integers. Alam naman natin, no, pag sinabi nating non-integers, fractions and decimals agad nang pumapasok sa utak natin. Okay, and yung mga hindi naman gano'n, no, meaning our whole numbers, these are what we call integers, no? Yung mga walang decimal, hindi walang denominator, no? So these are integers. Integers are divided into two, no? So we have the counting numbers and the negative numbers, no? So we have negative numbers, these are numbers below 0 basically, no? So yung mga basta may negative, no? Negative number 'yon. Then we have the counting numbers. This is composed of 0 and the natural numbers. No? So we have 0, of course 0, and the natural numbers, lahat ng 1, 2, 3, so on and so forth. Okay, so this is the mathematics family tree. So these are the common mathematical notations that we use, no, in conveying mathematical concepts and expressions, no. So expressions, equations, and concepts. So you may post the video and copy, no. So these are just some yung mga common. Of course there are lots, no. So if you have time to research, no, yung mga mathematical symbols natin, then please do so. Ayan, I presume you have copied, no? You have paused and copied the symbols, no? So let's proceed with mathematical expressions. So an expression is a finite combination of symbols that is well defined according to the rules that depends on the context. So correct arrangement of math symbols is used to represent the idea, but it does not contain a complete thought, and it cannot become determined if true or false, no? So, basically, parang ano siya, parang I forgot the English, I mean, yung term para sa, ayun, phrase, no? Para siyang phrase. 'Di ba? Sa English language, we have a phrase and a sentence. So, a phrase is collection of words, no? A phrase is a collection of words that does not convey a complete thought, basically. No, so ganun din dito. When we say expressions, these are mathematical phrases, no? Mathematical phrases that does not convey a complete thought. For example, we have the matrix of 1, 4, negative 2, 3. Like, okay, matrix siya, pero what are we going to do? Something like that. Now, for example, we have f of x. So, what are we going to do with f of x? No, that is a function, yes. Pero, what does it, I mean, what does it pertain to? What is the value? Then we have the set, no, of 1, 3, 5. So, okay, what are we going to do with the set? No, what is it equal to, or what is it not equal to? No, so yun yung mga ano natin, no. Mathematical expressions natin. And if we have a complete thought na, no, doon na pumapasok yung mathematical sentence. So, a sentence is a correct arrangement of mathematical symbols that states a complete thought and can be determined whether true or false. Okay, so we have, for example, no, 5 plus 3 minus 2 times 1 is equal to 6. No? So, alam naman natin, no? So, m dash, so we have 2 times 1, that is 2. So, 5 plus 3, 8 minus 2 is 6. No? So, yun. Okay, then we have 102,030 is much greater than 123, obviously. So, 6 digits yung 102,030 as compared to the 3 digits of 123. Then we have 78 is not equal to the square root of 125. So, yun, no, yun yung mga mathematical examples of mathematical sentences natin. Basically, sentences are combined, I mean, it is composed of or two expressions operated by either an equality sign or an inequality sign. No, that is what we call a mathematical sentence. Kumbaga, no, sa English language, yun yung mga ano natin, punctuations natin, 'di ba? We cannot say that a sentence is complete without proper punctuations. For example, period, exclamation point and the parentheses, 'di ba? Kasi if wala, parang ano ba yan, question ba yan, statement ba yan, things like that. No, so ganun din sa math, no? If there is no equality or inequality sign, then automatic it is an expression. But if there is already, and we have two sides, no, we have the left side and the right side of the equality or the inequality. So sentence na 'yon. Okay? So game, no? So we have here variable. So a variable, sometimes referred to as the John Doe of math. Now, it is any letter or representation used in place of an arbitrary value to express the correctness of a mathematical statement. So, for example, is there a number, let's say x, with the property that 2x plus 3 is equal to x squared? No, so a variable, kumbaga, it is representing something that we do not yet know. No, it is something representing something that is unknown. No, and in order to know what's the value of that unknown, we need to solve the inequality or the equality. Or basically, we need to solve the sentence, no, the mathematical sentence. For example, in this case, 2x plus 3 is equal to x squared. We all know that this can be rewritten in the form of x squared minus 2x minus 3 is equal to 0, which is the standard form of a quadratic equation. No? So, we can do factoring. So, we will have x minus 3 times x plus 1. Then, we can get the roots, no? So we will have x is equal to 3 and x is equal to negative 1. So those two number, no, satisfies the property of 2x plus 3 is equal to x squared, no? So this one is true. This mathematical statement is true. Now, if there is a number x with the property that 2x plus 3 is equal to x squared. Okay, so that's for the variable. Now, so for example, use variables to rewrite the sentences into mathematical forms. So we have four examples here. No, so are there numbers with the property that the sum of their squares equals the square of their sum? Then, given any real number, its square is non-negative. Are there any numbers, or are there numbers whose square are smaller than the numbers themselves? And a prime number is an integer greater than 1 and whose only positive divisors are 1 and itself. Okay, so let's try, no? Are there numbers with the property that the sum of their squares equal to the square of their sum? So when we are translating, let's say, translating English sentence into mathematical sentences, we need to group the words that we need to identify in the original given. For example, dito, are there numbers? No, yun yung first group natin. Then, sum of their squares. Then we have the square of their sums. Now, we need to identify these as these are the vital notations that we will going to use in the formation of the mathematical sentence. So, yun nga, X and Y, let's say I have two numbers. Let's say I have two numbers. No, in the most basic form. Kasi pag X lang, hindi siya R, no? It should be is there a number, no? Pero since we're dealing with numbers, no, at least no, we have two. Yan, X and Y. Then we have X squared plus Y squared, that is the sum of their squares, no? So just get the sum of each, then add them. Then dito naman, square of their sum, pag-aadin mo muna bago mo kunin yung square. Okay, kaya siya naka-quantity. Okay, and if we're going to equate this, no, kasi sabi dito equals, so we will have x squared plus y squared, or x squared plus y squared, is it equal to quantity of x plus y quantity squared. So what we can do is expand the binomial x plus y, no, so square of a binomial, so get the square of the two terms, then twice the product of the two terms, no. So we'll have x squared plus y squared is actually not equal to x squared plus 2x plus y squared. Kasi meron tayong sobrang 2xy. If 2xy is not there, no, kung wala tayong 2xy, then it will be equal. However, that's not the case. So hence, no, there are no numbers and this one is false. Okay, so yung proposition natin sa taas na are there numbers, no, so sagot dyan is none, or basically false, no, kung statement siya, magiging false siya. Okay, next. Given any real number, its square is non-negative, no? So let's segment yon. Let's segment the sentence, no? So given any real number, so R is any real number, that is our notation for the real number system. Then we have, let's say yung x is yung number na yon, no? So we have x squared is greater than or equal to 0. So yun yung ibig sabihin ng square is non-negative. And if we're going to combine this, no, insert this to a mathematical sentence, we have the function f of x, no, is equal to x is an element of the real number system where x squared is greater than or equal to 0. And this one is actually true. No, bakit? Kasi 'di ba, even for example, yung 1 and 0, doon tayo mag-start. 1 and 0. Kinuha mo yung square ng dalawa. 'Di ba, you also get 1 and 0 respectively. So it is equal. No, yung doon tayo sa greater than part, no? So for example, I get the square, no, of 3. I will get 9. So 9 is obviously greater than 3. For example, we have negative 5. What is the square of negative 5? 'Di ba, that is positive 25. So positive 25 is always it is greater than negative 5. So the statement here will always be true. Yeah. Then are there numbers whose square are smaller than the numbers themselves? No, so are there numbers? It's just simply a representation of any number. No, let's say any number whose squares are smaller. So the square of the number is x squared. Okay, than the number itself. No, so smaller than the number itself. Ayan, so less than, no, less than yung ano natin, yung tinutukoy natin. So if we're going to combine this, no, these parts, we will have f of x is equal to x, where x squared is less than 2x, no, which is actually false. Kasi nga sabi natin kanina, 'di ba, dun sa example number 2, ang square ng isang number will always be greater than itself, equal or greater than itself. So kapag ganito, no, so no, it's false, no. Ayan. Then last, no, a prime number is an integer greater than 1 and whose only positive divisors are 1 and itself. No, so let's represent x as the prime number. No, so we do not have a representation for a prime number kasi. So let's just take this as any number, no. Ayan. Then that's the prime number. Of course, sabi sa it is an integer, so we need to express x as an element of the integers, no. So yan. Then greater than 1, no, so x should be greater than 1, yun. And a and b are the divisors of the number. So if we're going to combine all of these phrases, no, or expressions to form the sentence, the mathematical sentence, we will have f of x is equal to a over b, no, so where x is an element of the is an element of the integers, no? And x is equal to a and b is equal to 1. Okay, kasi yung sinasabi dito, ano yung x is equal to a and b is equal to 1? You know, yung positive divisors are 1 and itself. Ayun. Okay? So, yan. Always true. No? So, basta prime number, automatic, yun lang yung kanyang divisors, no? 1 and itself. Okay, so kinds of mathematical statements, we have three main types of mathematical statements or sentences. No, so we have universal statement. So a certain property is true for all elements of the set. No, so for example, we have all positive numbers are greater than 0. No, so kaya nga siya naging positive kasi greater than 0 siya. Okay, then we have conditional statement. If one property is true, then some property, pero not all, must be true. Now, for example, if 378 is divisible by 18, then 378 is divisible by 6, no? So it may be true, no? So you still need to validate the proposition if this is the case. Kaya siya naging conditional kasi there will be conditions or there will be properties that the statement will not be true, no? So ayun. Okay, so ang clue word natin for conditional is if then, no? So, yung sa universal statement, I forgot to inform kanina. Ang ano natin this all, no? Yung all na sorry. Yung all na word or for all, yung other statements kasi for all yung ginagamit. Yun yung sa universal, then conditional. Yun nga, if then. Then we have the existential statement. No? So, given that a property may or may not be true, there is at least one thing for the property is true. No? So, for example, there is a prime number that is even. No? So, actually, there is, no? Ano ba yung prime number na even? 2. Diba? So ano ba yung divisors divisor ng 2, diba? It's only 2 and 1, pero it's an even. Pero other even numbers are not na kasi all even numbers are divisible by 2, diba? So ayun, so yun yung mga examples ng existential statement. Okay, so let's discuss universal conditional statement. So let's check the combination of the different statements that we earlier discussed. So, a statement that is both universal and conditional at the same time. So, basically, that's what a universal conditional statement is. Contains some variation of for all and if then. Yun yung mga keywords natin for universal and conditional respectively. For example, for all animals A, if A is a dog, then A is a mammal. No, so yun yung ating universal conditional statement, no? So we need to verify, is this really a universal conditional statement? You need to kailangan dapat makita niyo yung for all or yung all, no? At saka yung if then in one statement, no? So dito kita naman for all ito. Then yung if is this one, then ito. No? So we're going to identify what is the universal statement in this statement. Ano yung universal part dito? So this can be rewritten as if A is a dog, then A is a mammal. Yun yung universal. No? So, lahat ng dog ay mammal, basically. Then, for all dogs A is a mammal. No? So, yun yung ating condition na. Sorry, this is not conditional. Baliktad. No? So, yun nasa taas ang conditional. This is universal. No? So, let me correct that one. So, universal is for all dogs A is a mammal. Then, if A is a dog, then A is a mammal. Yun yung conditional natin. Okay? So, another one, no? So, we have here, for all real numbers x, if x is non-zero, then x squared is positive. No? So, ito yung mga pag nire-write natin, no? So, we have, if a real number is non-zero, then its square is positive. So, meron tayo if, then this is the conditional part. For all non-zero real numbers x squared is positive. So, this is universal. If x is a non-zero real number, then x squared is positive. This is the conditional. Then the square of any non-zero real number is positive. This is universal. No? Kasi firm yung statement natin dito. Wala siyang other conditions. So parang hindi siya nagdududa. Ganun. No? So, yan. And last is all non-zero numbers of positive squares. So this is also universal. No? So kasi meron tayong word na all. Ayan. Okay? So we have the universal existential statements, no? So when we say universal existential statements, a statement that is universal for its first part says that a property is true for all, and it's existential because second part asserts the existence of something. For example, every pot has a lid, no? So alam natin na lahat ng pot ay may takip dapat. No, dapat, no? So it can be rewritten as all pots have lid, no? So, meron lahat ng pots. This is universal. Then, for all pots P, there is a lid for P. Ito yung existential part, no? So, paano ba na natin malalaman kung existential? Meron siyang parang thought na there must be something that exists on this condition or on this property rather, not condition but rather property. Now for example, for all pots P there is a lid for P. However, not all pots have lids. No, hindi naman lahat ng kawali or kaldero na bibili natin ay may takip pa, or hindi lahat ng kaldero natin may takip pa. Basically, 'di ba? So for all pots P, there is a lid L such that L is a lid for P. So, yan, no? So, ang ano dito, ang existential part dito is actually yung such that, no? Yun yung word, yun yung keyword for existential naman, such that. Ayun. One of the keywords rather. Okay, then if we have here, every real number has an additive inverse. Now, when we say additive inverse, yan yung kapag inad mo yung negative part, that's the additive inverse, no? You will result to 0, no? So yun yung additive inverse. Okay, all real numbers have additive inverses, no? That's a fact, no? So lahat ng real numbers merong additive inverses. This is universal. For all real numbers there is an additive inverse for R, no? So this is also universal. Okay? So yun. Then we have existential universal statements, no? So for existential universal statements, baligtad naman. So a statement that is existential because its first part asserts that a certain object exists, and it is universal because its second part says that the object satisfies a certain property for all kinds of a certain property. For example, there is a person in my class who is at least as old as every person in the class, no? So merong isa, no, na for the fact is kasing edad, no? Who is at least as old, no? Kasing edad or kasing edad or pwedeng mas matanda, no? So yun. Can be rewritten as, some person in my class is at least as old as every person in my class. Okay, so this is existential because of the word some, no? Yon. Then we have there is a person P in my class such that P is at least as old as every person in my class. So yun yung existential part. Okay? So we have here there is a positive integer that is less than or equal to every positive integer. So ito yung mga rewritten statements. Some positive integer is less than or equal to every positive integer. No, so it's true, no? So yung ibang integers is either less than or equal to every positive integer, no? So but not all, no? So there's a positive integer m that is less than or equal to every positive integer, no? So this is universal. Yung nasa taas kanina is existential due to the word sum. No, tas dito naman affirm yung statement, so this is universal. There is a positive integer m such that every positive integer is greater than or equal to m. So, yung first part, yung universal, then yung second part, yung such that, yun yung existential. Then there is a positive integer m with the property that for all positive integers n, m is less than or equal to n. Okay, so, yun. This is universal naman, no? So, yan. So, that's the end of the lecture. So, thank you guys for listening. I hope you guys learned something. So, next meeting, we will discuss functions and relations. No? How do we identify relations? No? And how do we segregate functions from non-functions when we are talking about relations? So, stay safe. Okay? God bless, and I'll see you next meeting.